Pepper. We're going to go ahead and I'm going to go through your review slides with y'all real quick. Um, Please, 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 as I am going through this, first make sure that you have already finished these with your partner. If you and your partner are both done, y'all should be now seated separately from each other with your headphones on and watching the video and making tweaks and edits wherever you need to make them. Okay? So without further ado, let's go ahead and get started. So let's look at question number 1. Okay? So a student recorded the time it took for all the water in a puddle on a sidewalk to evaporate after a rainstorm. Which kind of energy causes water to evaporate? So when you look over here, we're pretty sure that it's probably not going to be sound or mechanical energy. So you don't yell at a puddle and it disappears, and you don't, just kick a puddle and make it disappear. It's typically, it comes from energy from the sun. Okay, and what is the energy from the sun that causes things to evaporate? Is it the light or is it the heat? If you said heat, you would be correct. So that means your answer should have been answer choice C for thermal energy from the environment. And for your reasoning, you could sit back and you could come in here and type out. Let me go ahead and do this. You could come over here and you could type heat is what causes water to evaporate. So thermal, or you could say and thermal energy is heat. Done. And that is your reasoning and your answer. Okay? Good job. Let's go ahead and move on to question number 2. Okay? Question number 2. A student records the following information about a planet. Which planet is the student studying? So if I look over here at my chart or my list, it says characteristics of a planet. Its largest moon is named Titan. It is made up mostly of gases. Oh, it's surrounded by rings. And it is the 6th planet from the sun. So if you know your planet order and you know the planet that has rings around it, and it is known for its rings, you should know that the answer is Saturn. Okay? Hopefully you got that. So one of the things that you could come over here and do for your reasoning is Saturn, because it has rings and it is the 6th planet in line. And you could also sit back and do like, my very excellent mother just served us nachos. And you could do something like that just to kind of show that you know, oh yes, I know that it's got to be this one here. And you can even come in here and just highlight it and be like, see, there you go, bam. 1, 2, 3, 4, 5, 6. Okay? Good job, y'all. Hopefully that helped y'all out. Make your tweaks as you need. Going on to question number 3. So the graph shows the changes in the lengths of shadows of a tree during part of the day. So if this day continues to be sunny, what's most likely going to happen to the length of the shadows from 2 p.m. to 4 p.m.? So if you're looking over here at the graph, you'll notice from 8 o'clock a.m. to 10 o'clock, what is happening to your graph? If you're saying it's going down, or so the lengths of our shadows over time, so what's happening from 8 to 10 is the shadow lengths are getting smaller. They're going down, or decreasing is a good word for that. And then what's happening from 10 o'clock a.m. to noon? If you said it's decreasing or going down again, very good. It is. So those shadow lengths are getting even smaller. In fact, they're almost at 0 here. Excuse me. But then you'll notice from noon to 2 o'clock, what do you notice starting to happen with those shadow lengths? They're getting longer, they're getting bigger. Okay, they are increasing in size. So the question over here is asking what's going to happen to the lengths of the shadows from 2 to 4. Well, if we noticed, it went down all the way before noon, and now we're seeing it start to go back up again after noon. It's most likely going to be answer choice C. Hopefully you got that one right. So answer choice C. And the reason behind that is we know that the shadows got smaller from the morning to noon. And now afternoon, we see that from noon to 2 o'clock, it's starting to go up again. So it makes sense that from 2 to 4, it will continue to go up. Okay, so let's go ahead and let's write our reasoning. And again, if your reasoning is close enough to mine, you should be okay. So I see the graph is beginning. Ooh, that's not right. To increase from noon to 2 p.m. So it will most likely continue to increase from 2 p.m. to 4 p.m. Okay? Hopefully that helped you guys out a little bit with that one. If you still have additional questions about the graph, ask me when I get back on Thursday. Okay, I know this one always trips some people up sometimes. Okay, moving on, let's go ahead and look at question number 4. So a teacher asks students to explain what they see in this picture. For students, explanations are shown in the box. They want to know which of the students gave a correct explanation. So, and we're checking all of the ones that apply. So let's go ahead and look down here. Sometimes I like to start at the end, so let's start with student 4. The picture shows the location of the sun at noon. Okay, well, just looking at this right here, if the sun was actually directly over the house here, like right down the middle on the center on top of it, then yes, that would be showing noon. But the sun is not there. So I'm going to have to say student 4 was not correct. So let me see. Do I have that as an option? Hold on. I'm going to try to show y'all one new thing. I don't think I can. I was going to try to show y'all the strike through, where you can strike through a word. Yeah, I'll have to show y'all that another time. It's pretty cool. But yeah, for that one, I'm just going to go ahead and leave it blank. If you look at student 3, the picture shows early morning. So look at where the sun is located on this graph. It's over here in the west. If the sun is in the west, it is doing what? If you said setting, you are correct. So the sun rises in the east and sets in the west. So that means that it is actually evening time or late or afternoon time usually. So about this time where the sun is located here, it's probably closer to it's a little bit afternoon. So I'm going to say maybe 3 o'clock, about 3 o'clock, give or take. All right, let's look at student number 2. The sun will reach the east horizon in less than 10 hours. Okay, so if this is 3 o'clock here, p.m., give or take, if you sit back and you think about that, in 10 hours, okay, well, even then, 12 hours from here is going to be 3 o'clock at night. So has the sun even made it anywhere close to the eastern horizon yet? No. And by the way, those of you who are not sure what the horizon means, this line right here that goes from east to west, that line is your horizon. That's kind of where the sun dips down below it. It's kind of the point where the sun starts to disappear and we can't see it anymore. Okay, so because the sun is about 3 o'clock right here, even 12 hours would be way too dark for the sun to start rising in the east. So unfortunately, student 2 was also wrong, but that was a tricky one. And then you have student 1. The sun will set in less than 6 hours. Well, if this is 3 o'clock, sun usually sets around 7, 8-ish, somewhere in there, about 7 o'clock. So is that probably true going from 3 to 7 o'clock? Is that less than 6 hours? Yeah, that one is. So we're going to go ahead and we're going to take our check mark and we are going to drag it to student 1 and we are going to leave it there. Ta-da! That was it. So this one only had one correct answer on it. Okay, and then for our reasoning, we're going to go ahead and we are going to put here student 1 was the only correct answer because student 2 was more than 10 hours. Student 3 should have said morning. And student 4 needed the sun directly above the house to be true. Bam, done. Okay, good job. Hopefully that helped clarify this one. I know this one was a little bit tricky, especially because of student 2. You had to really think about that one. So now we're going to go ahead and we're going to move into question number 5. Ooh. Now, question number 5, I'm not going to go into detail on this one because we sat back and we did this one for our SciPod yesterday. Okay, so you should have picked, the correct answer was this one here. Okay, so when you look, the monument over here is showing the Gobi Desert, okay, and that monument shadow at 3 o'clock. So if I'm looking over here, if this is PM, 3 o'clock PM, look at A, or look at this one over here at A. It's in the exact same spot. So if this is PM up here, this must be PM also. Same with this one. The sun's in basically the exact same location. So again, that's PM. And then when you look at this one over here, it's showing the sun directly lined up with the monument, meaning that is 12 o'clock noon. So the only one that made sense was this one here. And now you could sit back, and I told everybody else, go into your SciPod, copy and paste your sentence that you made from yesterday's SciPod, and just copy and paste it here, and there's your reasoning. You don't even have to write a new reasoning for it. Okay? Good, good. All right, let's move on to the next one. Number 6. Some characteristics of objects in our solar system are listed below. So you have characteristics of some of the objects in our solar system. They want to know which of the listed characteristics describes both the Earth and the Moon. So I am looking here at both the Earth and the Moon. So place a check next to each correct answer and leave the wrong answers unchecked. So here's what I'm going to do. Let's go ahead and look. So the core temperature is 15 million degrees Celsius. Okay, we remember Ms. Culpepper saying like 30 was hot. So 15 million degrees Celsius is like you can't even live there. So what is that one supposed to be representing? If you said the sun, you would be correct. So I'm just going to put, oopsie, yeah, let me move this. So that one was the sun. All right, so could not be that one. Meteor craters can be found on the surface. Ooh, so when I think about that one, I think back to our science lab that we did that day at my back table where I sat with you guys. So we noticed we had the moon had a bunch of craters on it. However, the Earth, oops, the Earth also did, because when you think about it, while the craters don't hit the Earth quite as much, they still can hit us. It's just our atmosphere is very protective, and so it helps kind of keep them from hitting quite so hard. Okay, so that's both the moon and the Earth. Let's look down at the next one, the third bullet here. The source of light is the sun. Okay, so if the source of our light is the sun, what would that be for? If you said for the Earth and the moon, again, you would be correct. So the sun is the source of light for us here on Earth, but it's also the source of light for the moon as well. So you'll notice the moon lights up, and that's how we get our moon phases. Where does that light come from? It comes from the sun. Okay, so far I've got 2, so I'll go ahead and I'll start moving my checks because that's what I'm looking for, moon and Earth. So there's one there. Drag this over here, put that one there too. Oops. Yep, dragging and dropping, guys. It's fun. Okay, so those 2 are correct. Water covers most of the surface. What do y'all think for that one? Yeah, there's only one that does that, and that is the Earth. So that one is just Earth, not the moon. So that one we will not check because we're still looking for both Earth and moon. And then last but not least, rocks and dust can be found on the surface. Can we find rocks and dust here on Earth? If you said yes, you are correct. Can we find rocks and dust also on the moon? That would be correct. So yes, that one is both the Earth and the moon. So I'm going to go ahead and put my labels next to them. Drag and drop my little check mark over here by that one. Try to cover the dot. There we go. And there we go. That's it. That's my answer. And so guess what? Having these things off to the side here, labeling them, that's enough work for me. I'm okay with that. So good job, y'all. Ready to move on to number 7. Okay. Well, good. I like this one. Okay, so the model below shows where water can be found during different stages of the water cycle. The question asks what should be added to the diagram to better explain the water cycle. Well, let's just for a minute go look at our answer choices and think about, okay, which one is necessary for the water cycle to actually do what it needs to do? Okay, do you need soil for the water cycle to work? No, we don't need soil for the water cycle to work. It's called the water cycle. We need water. Okay, look at this next one. The sun to provide energy for evaporation. Oh, we do have evaporation as one of the parts of our water cycle, but do we need the sun for the water cycle to work? Yes, we do. So I'm going to put a question mark by that one. Possibly my correct answer. Let me keep going and see. H, do we need rocks to make thermal energy for the water cycle? No, we don't need rocks to make thermal energy. In fact, rocks don't make thermal energy, do they? No, they can absorb some heat from the sun, but that's about all that they can really do. And that really isn't going to help a whole lot in the water cycle. So H is not the right answer. And then finally, do we need plants to give oxygen into our atmosphere for the water cycle to work? No. Them putting oxygen out into the atmosphere, all that does is help us to breathe. So our answer is actually G. That was the best one. So we'll go ahead and let me circle it. Go ahead and circle G. Okay, make that transparent. There we go. So I circle G. So the answer is G, because the sun is what makes water evaporate, and it will never stop. All right, because the sun never stops and the water cycle never stops. So again, they both have something in common. Eventually, one day the sun may stop, but it's not going to happen anytime in our lifetime, so no need to stress about that one. Good job. Hopefully y'all are staying with me. If you need to at this time, kind of take a pause, do a little stretch, take a minute, make sure you've written down all your stuff, changed what you need to change, and then you can resume the video and we'll keep going through the rest of them. All right, let's move on to number 8. So the picture over here shows a cumulonimbus cloud forming over an ocean, okay? And you see that's a really thick, puffy cloud, okay? Almost kind of looks like it may be a little bit darker up top here, right? You see how it's shaded a little bit darker in some spots? That's because it looks like it's filled with a lot of extra bits in it. Let's keep that in mind. So they want to know which statement best explains how the sun and the ocean interact to form a cumulonimbus cloud. So how the sun and the ocean interact. Okay, so let's highlight that and think about this. So if the sun and the ocean interact to form a cumulonimbus cloud, how does the sun and ocean interact with each other usually? If you said that the sun causes the ocean to evaporate, you would be correct. So that's kind of what we're looking at here. Now, real quick, just looking at the first word in each one of these, okay, automatically you should be able to cross out H and J. If you look, does light cause water to evaporate? Does light cause any of this? No. So the light energy, the only thing light energy can really do is give us sight, right? Or it can also help plants to make their food, okay? But light energy is not going to sit back and create condensation, and light is not going to cause, oh, it will cause reflection, but is that what helps us to create a cloud? No, none of that, okay? So that means it's either between F or G. So let's go ahead and look at answer choice F. Heat from the sun warms the ocean, so far so good, causing water to evaporate. I like it. The water vapor then condenses, to form a cumulonimbus cloud. Water cools, condenses, creates clouds, the 4 C's. So far, F looks like it might be my answer, but I'm going to check G just to be sure. So heat from the sun causes clouds in the area to gather over the ocean and form one large cumulonimbus cloud. Not necessarily. It's not really heat from the sun causing the clouds to gather in the area. What's happening is water vapor is evaporating into the atmosphere, cooling, condensing, and creating those clouds. Clouds are not created by anything else but water vapor cooling and condensing to create those clouds. So if you hadn't picked up on it, our answer is F. I'm going to use a triangle as my shape to shade it in. Okay, just make sure it's transparent, and there we go. My answer is F. So now to my reasoning, okay? In the water cycle, the sun evaporates water and turns it into water vapor. It will then cool as it goes into the atmosphere and create clouds. Bam, done. That's it. That's all you really needed. Which, if you look over here at my answer choice, is basically the same thing I wrote over here off to the side, just different wording. Okay, moving on to number 9. Good little review problem over here. All right, erosion is one of the processes involved in the formation of sedimentary rock. Which of these best describes the process of erosion? Okay, so I know y'all can't see me, but try doing it with your hands. Weathering breaks, erosion takes, deposition drops, right? You remember that? And then we have compaction is pressure, right? Pressure and heat. And then you have cementation, which is when all the pieces get glued together, okay? So if we look at our answer choices, rocks are broken into smaller pieces that remain in the same location. That is, if you said weathering, you would be correct. So I'm going to go ahead and change colors here. Weathering, okay? So that's weathering. Let's look at pressure compacts layers of sediment. Nope, we just said that one was compaction, right? So let's go ahead and do compaction. And then looking at H, pieces of rocks or soil are carried, from one place to another. Erosion takes it. I'm thinking this might be our one. Go ahead and write erosion. Put a question mark here. Let's see if I can get the question mark button to click. And then finally, this last one. Sediment grains fall to the bottom of a lake to form sedimentary rock layers. Which one was that? Deposition. Okay, so which one matched the best? That would be answer choice H. Very good. And honestly, having those words off to the side of the question like that, that's enough work for me on that one. I'm okay with it. Go ahead and highlight or circle H. Here we go. Good job. I will take that as showing our work. All right, moving into the next one. Number 10. Students investigate force. The masses they use at the beginning at rest on the ramp. The setup the students use is shown to the right. So if you look over here, we have the masses here. You have your spring scale you're using, and then the student is pulling up the ramp to measure how many newtons or how much force is needed to pull that mass up. So they want to know which change will reduce the amount of force needed to move the masses. So, this is fun. We're using that decrease and increase again. Okay, so if the ramp goes down, is that going to make it easier for us to pull or harder? It is actually going to make it easier. So the bigger the slope, it's kind of like, think about if you're walking up a hill, okay? If the hill is a lot flatter, is it going to take as much work for you to walk up it? No, probably not. But if you go up a really, really steep hill, are you going to have to really work hard to get yourself up there? Absolutely. So for this one, we want the ramp to decrease in height, so it's a lot easier for us to pull the mass across the way. So let's go ahead and we're going to circle answer choice A, because it just so happened to be the first one we used. Okay, transparent, and time for our reasonings. Let me get out my text box. And we're actually going to use my little example of the hill. So, like if you were climbing a hill, the steeper the hill, which is just, how steep it is or how tall that slope is that you're going up. So if you're climbing a hill, the steeper the slope, the more work it would be or it would take to climb. Where if it were flatter, it would be less work. Bam, done. Okay, hopefully that helped with this one. Good job, y'all. Almost done. We just have 11 and 12 to finish up. So number 11, a student uses a flashlight to shine a beam of light onto 3 different objects. So down here we have object 1, object 2, object 3. Okay, so we need to place the words into the correct spots in the table to describe what happens to the light beam as it interacts with each object. Okay, so let's look at let's look at object 1. So let me do little what I sees above each one of those to show my work. So object 1, I'm seeing the lights going in. It's going through object 1, but it's kind of like bending a little bit, right? It's kind of like not technically in a straight line really as it's exiting out. So let's say it is going through. But bending. Okay, and we'll talk about what that means here in just a second. So let me do, it's going through, but it's bending. I might need to make this a little bit smaller. Let me make that a little bit smaller. There we go. Okay. So there's object 1. Object 2 isn't going through at all, is it? No. So I'm going to go over here and I'm going to, oh goodness, trying to save some time here with this, but I don't know how much of a time saver this is. So it is not going through and looks like it is being what? Stopped, blocked, something like that. Yes, I know y'all can't see. Hold on just a second so I can scooch it up and maybe scooch it over a little bit. There we go. So I see it's not going through and it looks like it's being stopped or blocked on number 2. And then if we look over here at object 3, ooh, object 3 isn't going through either, but it is bouncing off. And I know that one pretty well. I think you guys probably know that one really well by this point. Let me go ahead and paste. Nope. Let me do, I messed that up. Paste. Here we go. Let's do right above object 3. It is not going through, but not bending. It is bouncing. Okay. So let's start with object 3. We know that one pretty good. When light bounces off of an object, it is being what? If you said reflected, that is the correct answer. So object 3 is reflected. Okay. And then we have these other 2. So let's see. We know that on object 1, light is going through the object. However, it's getting bent or messed up along the way. That one is our opposite of reflecting. That is our refracting. So number 1 should have been light being refracted. Okay? And then finally, if you look over at number 11, or I'm sorry, object 2, my bad, y'all. If you look at object 2, when light is not able to pass through, it is not able to do anything, okay? Out of these 3, which one sounds like light is being stopped or blocked? If you said absorbs, you would be correct. If we're talking about light being transmitted, that's light being able to go straight through something, like a window or something. Light being scattered, that's like the rainbow effect. So like when you put white light in a prism and all the colors of the rainbow scatter out, that's scattering. So the best answer choice for that one was absorbs. So absorbs goes up top here for object number 2. And there you go. That is question number 11 done for you. And now finally we have our last question. This is question number 12. So the map below shows weather conditions in North America for one day in October. The cold front continued to move farther south. Oh, so we need to know south, okay, for the next couple of days. They want to know what weather pattern most likely occurred in North Texas 24 hours after that cold front passes through. Okay, so if you look here, okay, look at your answer key up here. You have your cold front. Okay, that's this line right here. So typically when you have a cold front like this that's moving in and it's pushing the warm air out, so it's coming down this way and it's going to be shoving all that warm air out. And if you remember from what we learned, typically when the cold air moves out and the warm air moves out and that colder air pushes in, the warm air goes up, cold air comes down, and typically what you end up getting in that situation is, anybody have an idea? If you said it's going to rain, you would be correct. Yes. So you can always look back at our video with the meteorologist that I got y'all, the YouTube video I got y'all for the meteorologist. He was talking about that weather pattern typically with a warmth front. So typically with a cold front, moving warm air out, it causes rain to form. Okay, and whereas on the other hand, when you have like warm air masses coming in, what ends up happening is that's when you start getting things like hail or tornadoes and things like that. So the opposite will bring about the hail and the tornadoes. Okay? Alrighty. If that was it, then you may make sure that all of your answers were fixed and taken care of, and then you have my permission to go ahead and turn this in, okay? If you have any additional questions and you want to wait until I get back tomorrow to have them answered, you don't have to turn it in right now. We can turn them in tomorrow when I get back, okay? Thank y'all so much. Now that you're done, and if you've turned it in and you're finished, please go up to the sub and ask her for something else to work on if you still have some time. Thank you all. I miss you, and I will see you tomorrow. Bye.